Hello class, today we will discuss cycloid, a subtopic of your engineering curve. Cycloid is a locus point on the circumference of a circle, a rolling circle. Suppose class, consider this is a circle and it is rolling clockwise direction, and suppose class after one complete rotation it covers a distance 2 pi r, and class suppose this is P, the position which we need to trace at the topmost point of the circle. Now class, see when that P that circle rotate clockwise direction, that P follow some path. First it will move downward up to the surface, then it will again move upward and attain a maximum height. So now class, the path followed by this P point is nothing but a locus, or we can say cycloid curve. So that class P point can lie anywhere on the circle. It may be at the topmost point, at the bottom point of the circle, or it can lie anywhere on the circumference of the circle. The concept remains same. We need to trace a path followed by that point when the circle rotate clockwise direction without slipping on a straight line. Either it is straight or horizontal line or straight inclined line. Okay. Now class, come to your assignment question 4. A circular plate of diameter 60 mm rolls without slipping along a straight line inclined 30 degree to horizontal. Draw the locus of point of its contact with the line if it complete one rotation. Name the curve. Draw tangent and normal to curve at a height of 45 mm. So now here class, our first step is draw the inclined surface, which is given class 30 degree. So now class, first we will draw a horizontal line okay. Then class, measure measure 30 degree now class, over that inclined line class, we will mark circumference distance. The radius of the circle is 30. So circumference is class 2 into pi into r. So it is coming class 188.4. So now class, measure 188.4 mm over the inclined line. Now class, measure approx 188. So now class, this is your 188.4 distance. Now class, at the initial point of the circle, make draw a perpendicular now class, on that perpendicular class we will draw a circle of radius 30 mm. Now class, measure 30 mm over compass. Now class, divide this circle into 8 equal parts. Okay. Now class, see, we divided the circle into 8 equal parts. Then class, we will divide this length also into 8 equal parts. So now class, just randomly mark 8 point over that line. 2, 3, 4, 5, 6, 7, 8. 3, 4. Now class, divide this line, inclined line, into 8 parts. Okay. Now class, the condition for the initial point P which we need to trace is given it at the bottom contact between the circle and the inclined surface. So suppose that point is your P which we need to trace. The locus of P we need to trace class. Now suppose class, this point is, suppose this point is 1, this point is 2, 3, 4, 5, 6, 7 and P. So now class, suppose 1, 2, 3, 4, 5, 6, 7, P. Now class, extend all points on the inclined line vertically up light and shade. Okay. Now class, after that, all points lying on the circumference of the circle will extend towards right, parallel with inclined line. Okay. Now class, suppose this point is your center C. So now class, extension of one, we will the extension of one where it bisecting the center extension, we give that point naming is C1. Similarly class, for extension of 2, an extension of C is C2, C3, C4, C5, C6, C7, CP. Okay, now class, see that circular disc will rotate clockwise direction. So now class, see when this circular disc rotate clockwise direction, so that 7 point will replace one position 1. So that 7 point will come here, and that P will move uh, will move and take place the position of 1. You're getting class, when it will rotate, the point 7 will come to the position of 1 and P will move to the position of 1. Position of 1 means class here the extension of 1. Now after that class, 6 will come, replace the position of 2, then P will replace the position of 2. 5 at 3, P at 3, 4 at 4, P at 4. Similarly class, when it will rotate class, the position of P is keep on changing. So now class, see when it will rotate, the first P will the tracing of P will follow class extension of 1, extension of 2, then extension of 3, then extension of 4, then extension of 5, then extension of 6, then 7, then P. So that's why class, we will mark all traces of P during B1 complete rotation. So the concept class which we follow here class, it is like this. Suppose class, this is the vertical diameter of the circular plate. The points which are lying left side to that diameter, to mark those points class, we will follow left hand side direction, and to mark class those points which are right hand side of the perpendicular diameter, those points we will mark class towards right. Again I am saying class, those points which are lying left of the vertical diameter we will mark towards left from the center, and those points which are lying right to the vertical diameter we will mark from the center towards right. So naming should be class, you can give anything, but points towards left and towards right we will follow. So now class C, suppose the initial condition center is C. After that class the next center position is your 1. Okay, so now class C, it is rotating in clockwise direction. That means class P will move over the extension of 1, then 2. So now class C, for C1 we will mark on the extension of 1 towards left, because that point 1 is lying towards left. So now class measure compass equal to the radius 30 mm. Then class from C1 we will mark on extension of 1. Okay, then class give naming P1. Now class center 2. So center 2 class, after 1 class that P will move over the extension of 2, and that 2 point is lying towards left. So class from C2 we will mark on the extension of 2. So this point is your P2. Okay, now class center 3. Now from 2 the extension of that point P will move toward the extension of 3, and 3 is lying towards left. So from C3 we will mark on left side over the extension of 3. So this point is your class P3. Now class C center 4 C4 and the extension of 4. So it is class at the topmost point. So this point is your class P4. Now class come to the center point C5. Now your P point will lie on the extension of 5, and that P5 point is lying towards right. So we'll mark from center 5 towards right. So that point is your class P5. Now class from center 6, P will lie on the extension of 6. So and the 6 point is again class towards right. So from C6 mark on right. So that point is your class P6. Now come to the center 7. Now your class, your P will lie on the extension of 7, and the 7 point is lying towards right. So class from C7 we will mark towards right. So that point is your class P7. Now class from consider CP, and this is the extension of your P. The curve will end at point P. Now we will join all points class P1, 2, P2, P3, P4, P5, P6 and P7 and P with free hand. So class, this is your required cycloid curve. Okay, this is your cycloid curve. Now class, suppose that P is lying at the topmost point of this circle. So in that case class, that P follow extension of 5 after 4. Suppose class, again I am saying, if that P point is lying at the topmost point of the circle, so from here that P follow the extension of 5 first. So that's from C1 class we will mark on extension of 5, and P point is lying, 5 point is lying towards right, so we will mark from C1 towards right. So always remember class, whenever you are marking on the respective extension of points from the respective centers, always see class first if that point is lying towards left or towards the right of the perpendicular diameter of the circle. If it is lying towards right, then we will mark right side. If it is lying left, then we will mark left side from the center. Okay, so now class, this is your required cycloid as per the given question. Now draw tangent and normal to curve at a height of 45. So class, first we will take a projection of 45. Suppose class, yeah, from here measure 45, 1, okay. So now class, this is the projection of 45. Then class, from the end point of the 45 height, draw a horizontal reference line and where that horizontal reference line at a height of 45 bisect the given cycloid curve, just find out that point and give the naming class. Suppose that point is your M. Okay, and class, this is your height 45. Okay, so now class, the point M, which is lying on the cycloid curve at a height 45, consider class uh, mark compass equal to the radius of the circle for 30. Then class, from M, cut on the extension of center line. See class, this is the point lying on the cycloid curve. From here, cut on the extension of center. So that point class is that is your point class when we cut from M over the center extension. Now class, from this point drop a perpendicular to the inclined surface. Okay, so now class, suppose this point is your N, and suppose class this center point is your CM. Okay, now class, join N with M. Now I'm saying class, join N with M and extend that line. That is your class required normal at a height of 45. And class, join M and center point light and shade. Now class, this is your normal. Now draw tangent to that normal. This is class your tangent. Okay. So class, this is your required tangent and normal at a height of 45. So again class, C concept is first take projection of 45, then extend that height where that projection of 45 bisect the cycloid, give naming M. From M, take radius compass measure for 30, then cut on this extension of center. That point class, suppose your CM. From CM class, draw vertical downward a perpendicular. Now class, suppose give that point naming N. Now from N to join M and extend, that is your required normal, and to that normal class draw a tangent. So this is the method to finding out the tangent and normal. Now class, give naming to the required question. This is the the this class 2 pi r 188.4. Class, this is angle is 30 degree. Okay, so class, this is your required solution of cycloid problem.